All right, in 6-1 we started with the introduction into similar polygons. So we talked about that by definition similar polygons are polygons that all have the same corresponding angles would be congruent and the corresponding sides would be proportional. So number 1 says to determine whether the polygons are similar. If they are, write a similarity statement and find the scale factor of, God bless you, EFGH to KLMN. So in order for them to be similar, all 4 angles in the first one have to correspond to a congruent one in the second one. Is that happening? Yeah. So I've got 1 arc, a 2, a 2, a 3, a 3, and a 4, a 4. That's all the angles. The second thing is all the sides have to be proportional. So if I went in order from like largest side, the largest side in the first one is 30. What's the largest side in the second one? 15. Okay. And then that needs to be equal to, let's go down in order. The next smallest would be 26, would go over which one? 13. 22 should go over 11. And then, God bless you, 16 should go over 8. What's true about all of those ratios? They would get reduced to what? 2 over 1, each and every one of those. If any one of those did not reduce to 2 over 1, these are not similar. All of them have to reduce to be the same. So the yes is my answer, that they are similar. And then it says, write a similarity statement. So I would say that EFGH is similar to KLMN. That's all that means. And the order should be the same, right? E has 4 arcs, K has 4 arcs, F has 2, L has 2, G has 1, M has 1, and H has 3, and N has 3. And then it says find the scale factor of EFGH to KLM, which is what? 2 to 1. Or 2 to 1. And again, make sure that you pay attention to the order of those, because if it had said KLMN to EFGH, what would my scale factor have changed to be? Good, 1 to 2. All right, number 2 says, in the diagram, triangle DEF is similar to HJK. Find the value of X. So DE would correspond to JH. They both have a measurement. So 12 to 8 would be my scale factor, which would be 3 over 2. Good. And then H corresponds to the 9. DF went with HK. So 3 over 2 should equal X over 9. 27 would equal 2X, and X would equal 27 over 2, which is 13 1/2, or 13.5. Okay, number 3 says 2 similar triangles have a scale factor of 5 to 4. Find the ratio of their corresponding altitudes and medians. So what would this be? 5 to 4. It's the same, right? The scale factor is going to be the same as the corresponding sides and the corresponding lengths within the triangle, which would be your altitudes and your medians. Number 4 says 2 similar triangles have a scale factor of 3 to 7. Find the ratio of their corresponding perimeters and areas. So what do we know about the comparison of the scale factor to the ratio of the perimeters? It's the same. So the perimeters would be 3 to 2. Did we talk about areas at all yet? No. So let's talk about what would happen if I had a triangle, 2 triangles, right? And let's say that the scale factor was 3 to 7. So if I drew the altitude of this triangle and the altitude of this triangle, it should be 3 to 7. Or at least it would simplify to be 3 to 7. You with me? So what should the bottom of this triangle also simplify to be? 3 to 7. So this would be 3 and this would be 7, or 3x and 7x. I don't know what the actual numbers might be, but the ratio would be the same. So if I asked you for the area of the first triangle, how do I find area of a triangle? 1/2 base times height, right? So this would be 1/2 3 times 3, or 9 over 2. And this would be 1/2 7 times 7, or 49 over 2. So the ratio of these areas would be 9 over 2 over 49 over 2. Keep, change, flip, and what happens to the 2's? Cancel, and the ratio is 9 to 49. What's the relationship from the scale factor to the ratio of the areas? Emily? It's squared, right? Multiplied by itself. So let's see if that works every time. Let's try different measurements. Let's make it easy on ourselves and make it a nice even number, okay? So let's say I've got a triangle and another triangle, and let's say the scale factor is 10 to 12. So this would be 10, this would be 12, this would be 10, this would be 12. Area here, 1/2, 10 times 10, 1/2, 12 times 12. So 1/2 of 100, which is 50, 1/2 of 144, 72. The ratio here would be 50 to 72. Is that simplified? This would be what? Cut it in half, 25 to 36. And then cut my original scale factor, reduce that. What do I get? 5 to 6. What's the relationship between this and this? They're squared. So it's going to happen every time. So if I was given, we know that the ratio of the scale factor is going to equal the ratio of the sides, and it's going to equal the ratio of the perimeter. What we just proved is that if I square it, equals the ratio of the areas. So if I told you that the ratio or the scale factor of two similar polygons was 5 to 11, what would be the ratio of their perimeters? Perimeters. 5 to 11. What would be the ratio of the side length? 5 to 11. What would be the ratio of the areas? 25 to 121. Does everybody understand that? Yeah? Okay.
How did you get, when you have the 49 over 2 and the 9 over 2, how did you get 9 over 49?
I did keep change flip. So I did 9 over 2 over 49 over 2, and then it's a fraction within a fraction. So take 9 over 2, change it from division to multiplication, and then flip 49 over 2. So it would look like this. It said 9 over 2 over 49 over 2. And over means divided by, right? This is really divided by 49 over 2. So that becomes 9 over 2 times 2 over 49. And then these cancel. So when you've got a fraction within a fraction, you're just going to do keep change flip or stay change flip. Okay, so we just established that the two side lengths that we have that are corresponding are EF and BC. And it said ABC to DEF, so I'm going to put 19 and 4/5 in the top, over 9 in the bottom. Can't have a fraction within a fraction, so I'm going to convert that top number to be a mixed number. So 9 times 15 is 95, plus the 4 is 99 over 5. So I just converted 19 and 4/5 into improper fraction, which is 99 over 5. That goes over 9. So you've got 99 over 5 divided by 9. So I keep change and flip. Change to multiplication. Flip 9 over 1 would become 1 over 9. And then 9 goes into 99 11 times. So my scale factor is 11 over 5. And then 24 said find the unknown side lengths. So let's say AC, let's call this X, and ED, let's call that Y. So 11 over 5 equals X over 10 and 2/5. Because those two sides are the ones that match up. With me so far? So then this is 11 over 5 equals X over 52 tenths. No, 52 fifths, sorry. Just convert that to an improper fraction. and then cross multiply. So 11 times 52 over 5 would equal 5 times x. This is 572 over 5 equals 5x. And then divide both sides by 5. And dividing by 5 is the same thing as multiplying by a fifth. So 572 over 25, which becomes that 22 and 22 25ths. And then I have to do the same thing for the side that we marked as y. So 11 over 5 equals, and we went big triangle to small triangle, so I have to do the same thing, 22 over y. And then 11y equals 110, and y would equal 10. So the numbers in the quiz are not that ugly, but the process is the same. So you want to make sure that you understand. So you have to set up the scale factor and then set it up equal to the ratio that you have, that you either are missing a term or whatever it is. So in the next two sections, in 6.3 and 6.4, by the end of 6.4, you're going to learn 3 total ways. So they're shortcuts. Just like we had shortcuts to proving triangles are congruent, we have shortcuts to proving triangles are similar. So yesterday, if I asked you 2 things were similar, you had to show that all of the sides were proportional and all of the angles were congruent, right? That's how you would have shown me something was proportional yesterday. If we're talking about triangles, then we narrow it down to postulates, and this is the first one. Angle similarity. And this says that if 2 angles of one triangle are congruent to 2 angles of a second triangle, then the 2 triangles are similar. So again, this only works on triangles. I can't use this on a quadrilateral. It's got to work on triangles. But if I wanted to show that 2 triangles were similar, and I have 2 pairs of angles that are marked as congruent to each other, like this, A is congruent to D and B is congruent to E, now I can say that those 2 triangles are similar to each other, and the reason would be the angle postulate, or AA postulate. So these are just simple yes or no answers. Tell whether triangles are similar or not similar. So we're looking to see if each of these triangles have 2 pairs of angles that are congruent. So look at A. What information is given in A? Think about, first of all, identify the 2 triangles. There would be this little one, and then there would be this big one. So what information do I know about those 2 triangles? Okay, you would have to know that they're congruent on the other side, so that it is parallel. She said that it would be, you're talking mid-segment, right? Yeah, which they are parallel, but we don't know that it's the midpoint. What else could you tell me about these 2 triangles? What do they share? Emily? That top angle is part of both of them. So if I just found one of my 2 A's, yes, right? That's 1 pair of angles that are congruent for each triangle. What other piece of information is here? Oh,
2 lines are parallel.
2 lines are parallel. So what do we know about parallel lines? Why would they give me parallel lines? Are there special angles formed by parallel lines? Alternate interior, alternate exterior, same side interior, or corresponding. So alternate exterior is going to bring me to the outside of the triangle, right? Like that would be like that angle and that angle, which doesn't help me out. Alternate interior, one would be on the outside, one would be on the inside. So that doesn't help me out. Same side interior just says they're supplementary, and I'm trying to prove that they're congruent. So that leaves what? Corresponding. So this angle here corresponds to this angle here. Everybody see that? And if the lines are parallel, those 2 angles are congruent. And I already have 2 pairs of of congruent angles. Is there a third? Yeah. 2 reasons. Why? One is third angle's congruence. What's the other? There's another transversal on the other side, so I could have used that angle. So I could have done both corresponding angles and not the reflexive, right? Or I could have done the reflexive with either one of those if this was an actual proof. All right, B, a little bit more obvious, right? Yes or no? Yes. Okay, you've got two pairs of corresponding angles. C. What piece of information do I have? They share a side. These angles are marked as congruent, so I have one pair. What else is given you? Emily? I've got the side. What else is given to you? Well, the angle's bisected, yeah, but what else is given to you? Haven't used? Leah? These two sides are congruent. What does that tell you? So you could go the long way around, prove that these triangles are congruent. If the triangles are congruent, their corresponding angles are congruent. What's shorter than that? What was it called when we had a triangle with two sides that were congruent? Without proving they're congruent. What did the isosceles triangles tell you? If the two sides are congruent, then the angles opposite them are congruent. So if I ignore that middle line, this is an isosceles triangle. Do you see that? And if that's the case, then the two angles opposite those congruent sides are congruent. That's the base angles theorem. So are these congruent? Yes. Similar. These are actually congruent, which obviously means that they're similar. They don't have to be congruent to be similar, though. Okay, and then D. So this one's a little bit harder to see. This is one triangle here. And this is the second triangle here, the big one. So what piece of information do you know right off the bat? The two angles that are marked. So I've got one of the two A's. Then what? They both share this angle. So would that angle be congruent in each one? Yes. So, right now, angle similarity is the only thing that you know. Obviously, by the time we get to the next section, you're going to loop in a couple other ones. So you want to start to think about, yes, they're similar, and why. Okay? But this question really just said, tell whether they are or not. Alexis?
Are these just when it's kind of here? Is it going to be like we're using them in proofs?
You are going to eventually use them. Just wait. Even in today's notes, you're going to see them in proofs. Not for the quiz, but by the test, you're going to definitely see a proof. Okay? All right, so this one says to find x. So I've got two triangles, a little triangle within a big triangle. I've got this triangle here. And then I've got this triangle here. So before I do anything, I have to establish, are these similar triangles? Yeah, right? The top angle is shared, that's reflexive. And then I've got the parallel lines again. So these are similar, which means their sides would be proportional. So what's the left side of the small triangle? 3. What's the left side of the big triangle? 4. So that's my scale factor. Small triangle to big triangle would be 3 to 4. So if I want to use the right side, what's the right side in the small triangle? And what's the right side in the big triangle? X is just from here to here, right? 5 plus x. Does that make sense? So you got to look at sides as if it's the side of one triangle and the side of the other. So little to big would be 5 to this whole side, which would be x plus 5. Now how do I solve that? Cross multiply. So 3 times 5 plus x equals 5 times 4. I get 15 plus 3x equals 20. Subtract the 15. 3x equals 5. Divide by 3. X equals 5 over 3, which was 1 2/3. God bless you. Remember, if I'm setting up a scale factor, that I want to keep it improper, but if you're solving for the length of a side, you want to make sure it's a mixed number. Alexis. I distributed the 3 to both the terms inside the parentheses. All right, this one says, A, triangle ABC is similar to triangle. So the first thing I have to do is actually figure out what's similar to what. So if I look at my triangles over here, again, you've got a triangle within a triangle. So I've got this triangle here. And then I've got the big triangle here. Are these triangles similar? Yeah, reflexive side and corresponding again. So now the order of the letters is what's important. So if this, obviously B matches B. And then this angle would match this angle. This angle would match this angle. So pay attention to the order of the letters. The first one said A, then B, then C. So A has 3 arcs on it, which means what letter is going to come first? E. B has 1 arc on it, which means what letter is going to come next? B. And C has 2 arcs, which means D. So the order of the letters is important there. If you rearrange those letters, this question is wrong. Okay, now I have to establish a scale factor in order to figure out the missing side length. So look back at my triangle. If I go right side to right side of this triangle, then I have 3 to 3 plus x. There's an unknown there. If I look at the, like what appears to almost be a hypotenuse, the longest side, the comparison is y to 8, so there's an unknown there. The only side that I have both of is that bottom side. So the bottom side, the length of the smaller triangle would be what? 4, and the length of the big triangle would be 7. So this is my scale factor. Still with me? So now if I want to solve for y, 4 over 7, which is the small triangle to the big triangle, would equal what? Y over 8. And then I just cross multiply. So 32 equals 7 times y, divide by 7, and y equals 4 and 4/7. Yep. You can put it as a decimal, just make sure it's not like a repeating decimal. So it's probably easier to leave it as a fraction, but you can always put, like if it's a 1/2, a 0.5 is fine. It's just like if it's 2/3, you don't want to put 6666667, right? You want to make sure that it either terminates or leave it as a mixed number. All right, C says BE over BA. So if I follow along in the triangle, BE is the smaller part, or the right side of the small triangle. BA is the right side of the big triangle. So what other side ratios is this equal? BD over BC, good. And those letters could be switched around. It could be BD, it could be CB, it doesn't matter. And then what's the last one? It's the last pair of corresponding sides. So we're going small triangle to big triangle, which means, good, ED over AC. And then D wants me to solve for X. So I'm still using the scale factor of 4 to 7. 4 to 7 is a side in the small triangle to a side in the big triangle. So if I want to solve for X, what goes in the top? 3, and in the bottom? 3 plus X or X plus 3, good. And then cross multiply. 4 times X plus 3 equals 3 times 7. 4X plus 12 equals 21. 4X, subtract the 12, equals 9. and x equals 9 over 4, which is 1, nope, it is 2 and 1/4. So given AC is parallel to D or to BD, prove that triangle AOC is similar to triangle BOD. So hopefully at this point you're not like, oh my gosh, how do I prove triangles are similar? You only know one way, right? Which is angle-angle similarity. So your goal is to prove that two angles in the first triangle are congruent to two angles in the second triangle, okay? Again, by the end of the next section, we're going to throw two other ones in there. So you might get a little bit more confused because you have three options, but for right now, you only have one way. So your entire goal is to figure out what two angles in the first triangle are congruent to what two angles in the second triangle, and how do I prove it? So where would I start? With the given. So number 1 says AC is parallel to BD. Then what? I could do vertical angles. So state the obvious. Make it easy on yourself, which is angle AOC is congruent to angle DOB. And that is the vertical angles theorem. So this one matches this one. Then what? Not corresponding, so think, yeah. Okay, so these are my parallel lines. I only have, well, I have two transversals. Let's pick this one. Okay. So this time I've got alternate interior, right? This angle and this angle, C and D, are alternate interior. Does everybody see that? So I can say that angle C, and it's not shared, so I can use one letter, is congruent to angle D. And it's alternate interior angles theorem, which says that if two lines are parallel, their alternate interior angles are congruent. Could I have done the other transversal? And then what would I have said? A is equal to B. Good. So you could do either one. So now do I have enough information to prove these triangles are similar? So AOC is similar to BOD. And the reason is angle-angle similarity. Not so bad, right? Questions overall?